the geometry of a complex number in which 1 minus z2 it's equivalent to the distance. Z is moving around this bisector line of the line circle, इसको Apollonius circle भी बोलते हैं. Three different cases. Like here you will find an ellipse, you will not find any locus. Okay, so Z lies in this extended line. You will find hyperbola and transverse axis का length. Understand it very well. If not, don't worry. Work it, test yourself here. Bye. Good night. Okay. Welcome to this solo leveling journey. Today we are gonna complete the geometry of a complex number, in which we will study about the distance formula, the distance between two complex numbers, and later section formula internally as well as externally. And after that, the most of the classes will be based on the locus based on modulus. Okay, so these three topics, and along with this some questions on previous topics like de Moivre's theorem, nth root of unity based. Okay, so let's start. First, distance formula. The distance between two complex numbers like z1 and z2, these two complex numbers in this argand plane, you have to find this distance. Okay, so this distance you have to find. First of all, it's the distance is equal to mod of z1 minus z2. It's equivalent to the distance. How this is? Okay, so it's a comma b. We know we can convert any complex number a plus ib in the form of a comma b. Okay, one thing, that the complex number always acts as a point. Like in geometry, we know that any point, any moving point, right? In the same way, complex number also, this is c plus id, मान लेते हैं, c comma d, we can convert it into this. Now find first z1 minus z2 is equal to, we know that the difference between two real portion, that is a minus c, comma, we know that I into the difference between two imaginary portion. Now if we put mod here, like mod of z1 minus z2 is equal to a square root of a minus c square plus b minus d square. This is as same as the distance between two points in any geometry. Okay, so and this is also these 2 points, so that's fine. I hope it's done. Now mod of z, we already studied it. It's nothing but the distance from this z, a complex number, from the origin. So mod of z is nothing but the distance from origin. Okay, we will solve a problem based on this, and a mixture of two two theory, that is this and nth root of unity value problems. Okay, the second one is section formula. It's as same as the normal geometry, like these 2 points z1, z2. Here z1 and z2 are two fixed number, okay, fixed complex number. Now if this p a point, it will be also a complex number. If it divides this these two complex number in the ratio of k is to 1, then what will be that p is simply the same geometrical phenomena of normal Cartesian coordinate. In the same way, it just you need to do k z1 plus k z2 plus k plus 1. If we put z1, the value of z1 and z2, then it will be reduced into x plus iy form, okay, complex number form. This is if externally divided, like z1 here, z2 and q एक पॉइंट है जो इन दोनों को एक्सटर्नली k:1 रेशियो में डिवाइड कर रहे हैं, then what will be q here? Q is nothing but then k z2 minus z1 by k minus 1. This is okay. It's as same as normal geometry, okay, just complex numbers form. This is distance d, okay, this distance. I hope it's clear. Now one thing, if z1, z2 and z3 are three vertices of a triangle like this, z1, z2, z3 are three vertices of this triangle, then the center of gravity C of G will nothing but z1 plus z2 plus z3 by 3, okay. सिंपली याद रखना है, नॉर्मली जो जियोमेट्री आप लोग कार्टेशियन कोऑर्डिनेट्स में यूज करते हैं, यहीं पर भी सेम चीज है, केवल कॉम्प्लेक्स नंबर दिया हुआ है, नथिंग एल्स, ओके. यू हैव टू जस्ट रिमेंबर इट. नाउ लेट अस सॉल्व द क्वेश्चंस. ओके, क्वेश्चन नंबर 37. फॉर एनी इंटीजर k, अल्फा ऑफ k is equal to cos k pi by 7 plus I sin k pi by 7, where I is equal to root over minus 1, then the value of expression dot 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 जो भी लिखा है, okay. So yeah, it's a mixed nth root of unity and this distance formula. How, what is this given actually? अल्फा ऑफ k प्लस 1 माइनस अल्फा ऑफ k मॉड के अंदर दो कॉम्प्लेक्स नंबर के डिफरेंस में मॉड दिया हुआ है. दैट मीन्स दोनों पॉइंट के बीच में डिस्टेंस. इन द सेम वे इट्स आल्सो शोज डिस्टेंस, ओके. नाउ अल्फा ऑफ k इज गिवन अल्फा ऑफ k cos k pi by 7 plus I sin k pi by 7, right? We can convert it into Euler form, e to the power I k pi by 7. Now we know that here e to the power I 2 pi by n, that is nth root of unity, right? 2 pi होता है यहाँ पर. So I के साथ pi के साथ हम 2 मल्टीप्लाई कर लेते हैं यहाँ पे, right? e to the power I 2 pi by, then it will be 14 here and k को हम लोग बाहर रखते हैं, okay. e to the power I 2 pi by 14, it's 14th root of unity. So alpha is what? Alpha, there are 14 values of alpha, you will get 1 and then alpha 1 dot 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 करके alpha to the power 13, it's 14th root of unity. So 1 alpha, alpha 2, right? Alpha 2 dot 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 alpha to the power, sorry, alpha 13. If you put alpha 1 2 3 dot dot, you will get these values. 14 the root of unity, here it's given. Now what is the first In geometry, we have already done this actually before. First, here it's 1, now this alpha 1, this alpha 2, and in the same line conjugate बैठता है यहाँ पे alpha 13, in the same way alpha 12, right? And what is we need to find this is given actually. This is actually given, like alpha k plus 1, k की वैल्यू अगर हम 1 पुट करेंगे alpha 2 when k is equal to 1, alpha 2 minus alpha 1, right? mod में ही दिया हुआ है alpha 2 minus alpha 1. alpha 2 is what? This. alpha 1 this distance is, मान लेते हैं ये distance है. now alpha 3 somewhere here, okay? alpha 3 is here, this is also D. We know that this n vertices will form n equilateral or regular polygon, right? Where each side is same, isn't it? Yes. So this value and this alpha 3 minus alpha 2, alpha 14 minus alpha 13 minus alpha 12, this all are same in this case, right? So here k equal to 1 to 12, you will get 12 into a. From this expression you just write down. I think here it's clear why alpha k plus 1 minus alpha k is equal to a. It's a because the distance between two vertices here are always same. So that's why alpha k plus 1 minus alpha k, alpha 4 minus alpha 3, it will also be the same, okay? So that's why this all values are same. हम मान ले रहे हैं कि वो जो वैल्यू है वो a है. So यहाँ पे टोटल कितना वैल्यूज मिलेंगे? 1 to 12, that is 12 values. So 12 into a, because in each case you will get 1 a. For 12 cases it will be 12 a. Now in the same way k की वैल्यू अगर 1 पुट करें तो alpha 3 minus alpha 2, alpha 3 minus alpha 2 is also same a. Here it's 3a you will get because k is equal to 1 to 3. So 3a, just simply as divide 12a by 3a is equal to 4. I hope it's clear. It's a mixture, you know. Okay, it had been एडवांस में आए थे शायद ये 2015 में. It's a tricky question. Okay, next. Okay, now this is important actually. The locus based on modulus. Here 2 or 3 things we should remember, that is Z1 and Z2, which will be given to you in the question paper. Okay, right? Z1 is equal to A on plus I B on. You can put right 3 plus 5y. In the same way, Z2 is also given, but you have to find the locus of Z, which is moving. Which is moving point, okay? You have to find the locus of Z here. Here in modulus case, we will complete 4 different form. You have to just remember the form, you know, to get answer quickly. And yes, so let's start from 1. The whole mod of z minus z1 by z minus z2 is equal to k. Well, we know that modulus is distributive over only multiplication and division. Here it's division, so just distribute it z minus z2. Okay, so what is given here? This is nothing but the distance from z1 to z, मतलब z1 एंड z दो कॉम्प्लेक्स नंबर है, उनके बीच में डिस्टेंस दिया हुआ है, इज इक्वल टू k इंटू के हो सकते हैं फ्रैक्शन में भी हो, k इंटीजर भी हो सकता है, इक्वल टू k इंटू mod of z minus z2. It means this is the distance between z and z2. Okay, z is दोनों साइड में सेम ही है, एक मूविंग पॉइंट है जहाँ से z1 एंड z2 का डिस्टेंस बोल रहे हैं. Okay, yes, here it's 2k's. Okay, when k is equal to 1 and when k is not equal to 1, you will get two type of equations from here. Now first, when k is equal to 1, what does it mean? It means the distance between z and z1 and the distance between z and z2, these two are both same. It means z is somewhere lying between the line segment of z1 and z2. Let's say how. This is z1, this is z2. This is the line segment. Now, if z यहीं पे lie करे, then this distance and this distance क्या इक्वल है? It can't be equal, right? z तभी ऐसा हो सकता है कि z से दोनों पॉइंट का जो डिस्टेंस है सेम हो सकता है जब z इन दोनों का बीच में लाई कर रहे हैं. ओके, क्योंकि नीचे भी नहीं हो सकता, साइड में भी नहीं हो सकता, ऊपर भी नहीं हो सकता, सेम केवल मतलब बीच वाला पॉइंट में तभी हो सकता है. देन इट विल बी डिवाइड 1:1 रेशियो, यू विल गेट. नाउ if you put z in this line anywhere, like above this, you will get the same distance. Here also you will get the same distance. So that's why z is moving around this bisector line of the line segment z1 and z2. So here the equation is, here is the locus of z is bisector line. Bisector line of z1 z2. Okay, the bisector line of z1 and z2. And how you will find this equation? From first z1 and z2, from these 2 points you need to find the slope of that z1 and z2, and then it's perpendicular to z1 z2. So m1 and m2 is equal to -1. From there you will get the slope of this bisector line, and then find the middle point of this z1 and z2 and use the normal equation of line, that y minus y1 is equal to m into x minus x1. Okay, I think it's clear up here. Now the second portion of this form 1 is when k is not equal to 1. What you will get here? You will get an Apollonius circle with okay. Now when k is not equal to 1, इसको हम लोग a पे लिख रहे हैं. Then actually, so the distance between z1 and z is equal to k times the distance between z and z2. Okay, so the line segment will be like this. Now from here you will get p is what? kz2 plus z1 by k plus 1. Okay, it's nothing but a circle. Actually a circle, इसको Apollonius circle भी बोलते हैं. Okay, how we will get this circle right now? Okay, If we draw a circle with radius this 1 unit, this is the circle. Okay, remember this one is not actual one, it's 1 unit as compared to this k. Okay, this you have to remember. Now here one thing, this is the diametric end, this is diametric end, one is p and another one is q. This q, the total length of z1q will be k and this will be 1. So q will divide z1 z2 externally, like p divides z1 and z2 internally with the ratio k is to 1. In the same way, q will divide z1 z2 externally with k is to 1. Then you will find the position of q, that is z2 kz2 minus z1 by k minus 1. So you find the two diametric ends, that is p and q of the circle, and the radius will be here pq by 2. Then you will find the equation of that circle, right? So what we have studied about this important locus on modulus. First form is when the whole mod of z minus z1 by z minus z2 is equal to k. Here will be two different category. When k is equal to 1, when k is equal to 1, you will get a bisector line between this z1 and z2. The second one is when k is not equal to 1, you will get an Apollonius circle with pq diametric end and radius pq by 2. Okay, now let us understand it clearly. Now one example is mod of z plus 2i is equal to mod of z minus 3i. It's the first case when k is equal to 1. So at first find z1 and z2. Z is clearly visible here, but z1 and z2 you have to find. What is z1 here? Z1 is z minus z1 is 0 comma minus 2 and z2 here 0 comma 3. 0 plus 3i and it's 0 minus 2i. Okay, now here in this case what we find? At first find the slope of z1 z2, slope of z1 z2, which is equal to y2 minus y1 by x2 minus x1. So 3 minus of minus 2, it is 5, y2 minus y1 by x2 minus x1, right? Okay, question was wrong. 3 plus I, so it will be 3 comma minus 1. Okay, 3 comma minus 1. Now y2 minus y1, that is 1 by 3 by x2 minus x1. So the slope of the vertical diametric, the slope of bisector line will be, bisector line will be 1 by 3 into m is equal to minus 1. So m is equal to minus 3. Okay, now the equation of now the middle point, like z, this is z1, this is z2. z1 क्या है? 0 minus 2, z2 is 3 minus 1. the middle point is 3 by 2 comma minus 3 by 2, right? Yes, and this is the bisector line. This is the bisector line. Now the equation of this bisector line is y minus y1, that is plus 3 by 2 is equal to m, it is minus 3 into x minus 3 by 2. Okay, so this is the equation here. Now one more way of solving this, simply put z is equal to x plus iy in both sides. Then what you will actually do, that you will find the real part of left portion plus I into imaginary part of left portion. In the same way, right side also. Now simply use the modulus, right? Root over x square plus y square, that is real part square plus imaginary part square, and simply calculate. You will find the same answer as it is. Okay? Yeah. Okay, question number 38 is, if the center and the radius of the circle mod of z minus 2 by z minus 3 is equal to 2 are respectively alpha comma beta and gamma, then find 3 of alpha plus beta plus gamma. Okay, so this is the equation of Apollonius circle where k is not equal to 1 and the value of k is here it's given is equal to 2. Then first find this p with the internal division formula. You will find p will be 8 by 3 comma 0. But here it's z1. What is z1? z1 is here imaginary portion of z1 is 0, simply real portion. So z1 is 2 comma 0 and z2 is 3 comma 0. Using these two, you will find the value of p with the internal division 2 is to 1, 2 is to 1, and the same with the external division q 2 is to 1. You will find p and q. Okay. Now from this you will find the center. What is the center? Center lies in the middle point of p and q, because p and q are two diametric ends. We all know this. So p center will be c is equal to 10 by 3 comma 0, using these 2 points, and then radius is pq by 2, or you can simply find, if this is c, then cq. C is also 10 by 3 comma 0, so cq, or you can simply find pq by 2. This is okay. Another type of like this, put simply z is equal to x plus iy, and then simply calculate it, then and you will get the same value as it is here. If you put z is equal to x plus iy, actually you will get an equation that is x square plus y square minus 20 by 3x plus 32 by 3 equal to 0. This equation. From this you will get f and g and c, and also the radius will be root over f square plus g square minus c. Okay, the same you will get this. Okay, so move on to the next topic. Okay, now form 2. Form 2 of this modulus based locus. What is form 2 actually? Mod of z minus z1 plus mod of z minus z2 is equal to k. Okay, here first you have to calculate. Okay, so this is what we know, that the distance between z and z1, and it's also the distance between z and z2 is constant. दोनों distance add करेंगे तो constant value मिलेगा. Now first you have to calculate z1 z2, that is the distance between z1 and z2, mod of z1 minus z2 and compare with k. Then compare it with k. Here three different cases, like case 1, you will get this k is less than mod of z1 minus z2, and third one you will get. Okay, now find, in this case, find the equation. Let's say z1 is this, z2 is this somewhere, this is z1, this is z2. So z1 z2, this is z1 z2, the difference between z1 and z2, मान लेते हैं कि ये d है. Now another point is z somewhere here above the line segment z1 and z2, मान लेते हैं कि z यहीं पर है. So the distance between z1 and z and the distance between z1 and z, this two. Well, this is a and this is b. We know that from triangle inequality, this a plus b will always be greater than equal to the third length of our triangle, right? This is a triangle. These two length, the summation of these two length will always be greater than equal to the third length, right? We know this. But here it says that k, that is this third length, is less than of the summation. So that's why it's invalid. ऐसा हो ही नहीं सकता. एक तो ऐसा हो सकता है कि k is equal to this distance, इसके साथ इक्वल हो सकता है. जब ये z इसके ऊपर लाई करेगा, then you will find this is z1 and z2. So ऐड करोगे तो z1 z2 इन दोनों के बीच के डिस्टेंस के साथ इक्वल होगा. पर कभी भी वो जो पॉइंट z है, अगर ऊपर लाई करे, नीचे लाई करे, राइट बाय कई जगह लाई करेंगे, तो हमेशा ये z1 z2 इस डिस्टेंस से बड़ा ही होगा, छोटा नहीं हो सकता. So that's why it's invalid and you will get here 5, no solution. Okay, now case 2. Case 2 is already taught, like how, when k is equal to mod of z1 minus z2. Like हमने कहा कि ये जो z वाला पॉइंट है, अगर किसी भी इस लाइन सेगमेंट से बाहर हुआ तो वो हमेशा z1 z2 से बड़ा ही होगा. लेकिन मान लेते हैं कि वो जो पॉइंट है z1 z2 के ऊपर लाइन कर रहा है, then only you will get this value and this value. When you will add, you will get the same z1 and z2. So here in this case, the locus of z will be moving around from here to here only. If z is outside this, in this side, then you will get that z2 plus z1, which is greater than this k. But here it's equal position. Here in this case it should be equal. Equal तभी हो सकता है जब z इस line segment के ऊपर lie करे. Okay, so here the location, the locus is simply this line. Okay, हाँ, इसका geometric interpretation geometrically हम लोग कैसे करेंगे? Like ये x है, y है, z1 z2. This is the locus. Z will move around this line segment only. Okay, I hope it's done. And third one is case 3. When k is greater than mod of z1 minus z2. This is z1, this is z2. Here you will find an ellipse. You will find an ellipse here. Okay, z will be lying here. ऊपर नीचे z will move around this ellipse with major axis. यही पे जो मेजर एक्सिस होता है, major axis will be equal to k, and this distance 2a e is eccentricity, we all know this, and this will be to focus. Okay, this is form 2. हम एग्जाम्पल देखेंगे इसका. Okay, now here example is, it's given that mod of z1 minus z2 is equal to 5, and z1 is equal to 4, 0, and z2 is equal to 0, 3, 0, minus 3, actually it's 0, minus 3. Then 3 cases we will discuss here. For first one, it's given that z1 and z2 के बीच में जो distance है, that's 5 unit, right? Yes. So mod of z minus z1, z minus 4 plus mod of z plus 3i is equal to 3. That is in the case number 1. So 3 is, first calculate z1 z2. Here it's given, so mod of z1 z2 is given 5. So 5 is more than, 5 is greater than 3. So here you will get no locus, that is 5. For this case, that is k is equal to, so the distance k is equal to between their distance z1 and z2. Here what you will find, the line segment, right? First put the point 0, 3, 0, 3, sorry, first z1 is 4, 0, 1, 2, 3, it's 4, 0. Another one, this is z1. Okay, now another one, 0, minus 3, this is z2, 0, minus 3. The line segment is this, right? This is the locus in this case. Okay, this is the locus in this case. And the third one, when k is greater than, when the k is greater than the distance between z1 and z2. Here it's 12, which is greater than 5. Okay, now here you will get an ellipse, this type of ellipse. Actually ऐसा होगा. Here ellipse with major axis is equal to 2a. 2a is equal to 12, and this distance is 2a. From here you will get a, from here you will get e, तो वहीं से b मिलेगा, and you will get the solution or the equation. I hope it's clear. Now we will move into the third portion, third form, that is form 3. Let me check. तो रहा है ना? Okay, now form 3. Okay, here it's simply, this is positive, here you will get in the negative, like mod of z minus z1 minus mod of z minus z2 is equal to k. You know, for negative we put extra mod. Why? It's because अगर इन दोनों का माइनस वैल्यू, डिफरेंस वैल्यू अगर नेगेटिव आया तो वो मॉड उसको पॉजिटिव में कन्वर्ट कर देगा. इसके लिए हम लोग मॉड एक्स्ट्रा पुट करते हैं, इसको लेके घबराना नहीं है. Here also 3 cases. Case number 1. For case number 1, let's say k is greater than. Oh, here is also first calculate z1 mod of z1 minus z2. First calculate it and then compare with k. Okay. So first, if k is greater than z1 minus z2, let's see. So मान लेते हैं कि z1 यहीं पे कहीं पे है, z2 यहीं पे. This is z1, this is z2. Okay. नाउ z एक मूविंग पॉइंट है, ऐसे मान लेते हैं कि z यहीं पे लाई कर रहा है। ओके इस बार हम लोग इसको नीचे में मान रहे हैं, z यहीं पे लाई कर रहे हैं। ओके सो द मॉड ऑफ z minus z1, that is the distance between z1 and z, right, and the mod of z minus z2, the distance between this, right, and the difference, मतलब इन दोनों का अब माइनस करना है। इसको अगर a मान रहे हैं, इसको b, इसको c मान लेते हैं, तो हमें क्या निकालना है? लेफ्ट हैंड साइड में क्या है? a माइनस b, राइट, a माइनस b। a पे क्या लिखा है? इट्स लेस देन, a माइनस b इज लेस देन c, राइट, नो ग्रेटर देन, greater than, sorry, is greater than c. This is a minus b. Okay, so a minus b is greater than c, but it's never gonna happen. Why? Because एक ट्रायंगल का दो लेंथ, दो साइड का डिफरेंस कभी भी तीसरे से बड़ा नहीं हो सकता, पर यहीं पे डिफरेंस जो है, दो साइड का डिफरेंस तीसरे से बड़ा बोल रहा है। It's never gonna happen. That's why in the same case here it's less than, in the same features, same characteristics we use, and you will get that in this case you will not find any locus. Okay, you will never find any locus. Now case number 2, when k is equal to mod of z1 minus z2. In this same case, z1, z2, this is z1, z2. If you put z here and here, you will find same case. Okay. Now, if we put z in this line, extended line, z, and in this extended line, okay, same extended line, okay, here z. So first take this z, okay, find the let's say this z is somewhere here, then the distance between z and z2 is this, and the distance between z and z1 is this. If you subtract these two, then what you will find? You will find this distance, which is equal to k, right? So z, z2 minus z, z1 is equal to what? z1, z2 is equal to z1, z2. It means z lies in this extended line. Okay, in the same way you can calculate this portion too. It will be also come under this locus. So in this case, when k is equal to mod of z minus z2, z1 minus z2, here the locus will be this extended line, the both side extended line. Now let's say z is here somewhere, what you will find? This distance minus this distance, दोनों का नेगेटिव, दोनों का सब्ट्रैक्शन कभी भी इस बड़ा लाइन के साथ इक्वल नहीं हो सकता. ओके, सो दिस इज द लोकस इन दिस केस. नाउ केस नंबर 3. Case number 3, when k is less than mod of z1 minus z2, here you will get a hyperbola. Okay, you will get a hyperbola. This is z1, this is z2. You will find hyperbola, and this is k is equal to transverse axis का length. ठीक है, okay. So from this case, when k is less than mod of z1 minus z2, you will get hyperbola with transverse axis is the line segment z1 z2. Okay, I hope up to this is clear. Okay, so now coming to fourth. Now form 4. Form 4 यहीं पर भी 3 केसेस होंगे. केस नंबर 1 C1 when mod of z minus z1 is equal to r. You will get a circle with radius. This radius is r. Okay, z1 here, z1 will be the fixed point and this is z1. Z1 is the center of that circle. Okay, this is. Now case number 2, you just need to remember this, all of these cases, so that you could answer quickly. Okay, now second case 1, that is z minus z1 mod of z1 is less than r. Here you will find also a circle, but here the radius, here also z1, but the radius in this case, the radius will be less than r. That means the circle is somewhere this. Okay, not the full r will capture here. Okay, now our third case, case number 3, mod of z minus z1 square plus mod of z minus z2 square is equal to z1 minus z2 square. Here it's also equation of a circle, okay, with z1. Yeah, in this case, the radius first. Here Z1 and Z2 are the two diametric end, okay, and radius, this radius you can say this is Z1 minus Z2 by 2, मतलब Z1 Z2 by 2, इन दोनों का बीच का दूरी का आधा. हाँ, you will find this also from this side too. Okay, this is and yeah, this center को find करना है. Z1 plus Z2, Z1 plus Z2 by 2. These are the 4 forms about about the locus on the basis of modulus of a complex number. I hope you have understand it very well. If not, don't worry, दोबारा देखिए. थोड़ा बहुत खुद भी. Okay, now कुछ questions है जो हम आपको दे रहे हैं. मतलब you have to find the locus of that equations which I'm giving you right now. Note it down with me. Okay. मोहब्बत एक एहसास है कि पावन सी कहानी है, कभी कभी रहा दीवाना था, कभी मेरा दीवानी है. ये तो आप लोग सुने होंगे. द फेमस पोइट मिस्टर कुमार विश्वास, उनका लिखा हुआ. मैंने लास्ट क्लास में कहा था ना कि एक खूबसूरत पोइट्री सुनाएंगे अगली क्लास में, तो वो वही है कि मोहब्बत एक एहसास है कि पावन सी कहानी है, कभी कभी राह दीवाना था, कभी मेरा दीवानी है. यहाँ सब लोग कहते हैं मेरी आंखों में आंसू है, जो तू समझे तो मोती है, जो ना समझे तो पानी है, जो तू समझे तो मोती है, जो ना समझे तो पानी है। आई होप अच्छा लगा होगा, नहीं लगा होगा कोई बात नहीं, अच्छा लगा होगा तो शाबाश दीजिएगा। ओके, नाउ एग्जांपल फर्स्ट, एक्चुअली यू हैव टू मैच द लेफ्ट हैंड साइड विद द राइट हैंड साइड। यहीं पे मैच वाला लिखा है, मैं बस सिंपली क्वेश्चन दे रहा हूँ, आपको फाइंड करना है कौन सा लोकस के अंदर आएगा। फर्स्ट, mod of z minus 3i by mod of z plus 2 is equal to 1। ये मेरे ख्याल से पहला वाला केस में आ जाएगा ये, यस पहला वाला केस में। सेकंड क्वेश्चन इज mod of z minus 3i, note it down with me what happened with this, plus mod of z plus 2 is equal to root over 14. In this type of question you have to find first the difference between z1 and z2 and then compare with k. Okay, third one is z minus 4i is equal to 3 into mod z. Then in this case you have to first little bit simplify, mod z को इस साइड में लेके आओ, उसके बाद करो, उसके बाद z1 and z2 फाइंड करो एंड देन डॉट 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 जो भी करना है। फिफ्थ क्वेश्चन इज mod of z plus 6i plus mod of z minus 2 is equal to 2 root 10. Okay, ये fifth one is sorry ये fifth था, नहीं, fifth one is mod of mod z minus mod z minus 5 is equal to 4। इन सब का लोकस फाइंड करना है आपको। ओके, you have to find a locus। Seventh one is mod of z minus 3 minus mod of z plus 7i, it's the third form, is equal to 21। now g is mod of z minus 2i is equal to 5, and now h is mod of z plus 3i whole square plus z minus 4 square is equal to 25। ओके, ये होमवर्क है, टेस्ट योरसेल्फ हियर, TY टेस्ट योर प्रोग्रेस हियर। ओके, फाइंड 6 क्वेश्चन दिया हुआ है, इन सब का लोकस आपको बताना है। ओके, जस्ट अपने साइड में लिख लेना है और उसके बाद खुद ही से अपना आंसर मैच करवाना है। सेकेंड वन इज B is mod of z minus 3i, okay, plus mod of z plus 2। Okay, so question number 39 is, for all complex numbers z satisfying the first equation, that is mod of z1 is equal to 12 and second equation mod of z2 minus 3 minus 4i is equal to 5, then you have to find the minimum value of z1 minus z2। okay, z1 and z2 का minimum distance आपको find करना है। Here z1 and z2 itself the moving point, okay, z1 and z2 itself a moving point, two different moving point, that's why it's given z1 and z2। okay, in the first equation, that is mod of z1 is equal to 0, it's actually written as mod of, it's actually written as mod of z1 minus 0, 0 plus 0 is equal to 12, get it? Yes, and the second one, it's given actually mod of z2 minus 3 plus 4i is equal to 5। These two are two different circle, it's a circle with radius 12, it's also a circle with radius 5, but its center lies 3,4 in the 3,4 point and it's 0,0। so first draw it, okay, दिस इज 0,0. नाउ 12 यूनिट डिस्टेंस, मान लेते हैं कि ये 12 यूनिट है. I hope it looks like a circle. Yeah, मान लेते हैं कि ये this one is this mod of z1 is equal to 12. Second, this one, okay, 0,0. Its center lies 1, 3,4, right? Yes. This will be 6. 12,0. This will be 6. This will be 3 then, comma 4. This is also 3. This is 6 then 4. Somewhere here 3,4, right? Center. Now it's and this distance is 5 unit. This distance is 5 unit. Okay. This is 0,4. This is 3,0. So this will be 5 unit. Now encircle करके इसका रेडियस कितना है? 5 unit. So you have to draw a circle from here. Let's suppose it's a circle. Circle जैसा लग नहीं रहा, but yes, let's suppose it's a circle. Let's suppose it's a circle of radius 5 unit. Okay, and is this total distance is 12 from this to this. Now z1 is moving around this circular line. So z1 कहीं भी हो सकता है. In the same way, z2 is also moving in this circular line. Okay. Now say maximum distance कब होगा z1 and z2 का? z2 इसके बाहर नहीं जा सकता, z1 इससे बाहर नहीं जा सकता. So मान लेते हैं कि z1 जो है यहीं पे है and z2 यहीं पे कहीं पे है. तब डिस्टेंस कितना होगा? कितना होगा? ये सेंटर से 12, थोड़ा सा ज़्यादा हो सकता है. पर अगर यहीं पे लेते हैं डिस्टेंस यहीं से एंड दिस सेंटर से, मतलब 0,0 से, then it will be 12 plus 5. This will be maximum. No. When z2 will be lie here, z2 here, then it will be maximum through this whole 5, 5, 10 plus this 12, 22. Okay, this will be maximum 22. You can find from this way too कि z1 मान लो कि यहीं पे कहीं पे है z1 and हाँ z1 यहीं पे कहीं पे है, z2 यहीं पे कहीं पे, तब वो मैक्सिमम वैल्यू नहीं आएगा. मैक्सिमम वैल्यू तब भी आएगा जब दोनों पॉइंट ये इस साइड में होगा, ये z1 एंड z2 इसका ऑपोजिट साइड में यहीं पे कहीं पे होगा. दोनों का टोटल डिस्टेंस ये 12 यूनिट एंड देन 5, 5, 10, 22 विल बी मैक्सिमम. बट यहीं पे हमें क्या पूछा गया? मिनिमम डिस्टेंस. पर मिनिमम दिस z1 and z2 both should be in a same direction in a straight line from the origin. मान लेते हैं कि इसी डिस्टेंस में यहीं पे z1 है और z2 कहीं पे यहीं पे होगा, तब भी ये मिनिमम डिस्टेंस होगा. अगर z2 यहीं पे कहीं पे होगा then it will not be minimum distance. Minimum distance is the shortest straight line. This is minimum distance and it will be, this is whole is 12, this is O and this is मान लेते हैं P and this is Q. So the distance here you should find PQ, right? And PQ is OP minus OQ. OP is what? OP is 12 unit. It's given the radius of first radius of this circle 12 and OQ is 5, 5, 10. is equal to 2. So the answer is B. I hope यही तक clear है. This was the locus based on modulus and section formula, and also the distance between two complex number. I hope it's clear. Almost 1 hour हो चुका है. मेरे तरीके से देखे तो ऑलमोस्ट 2 घंटा हो रहा है, क्योंकि लिखना पड़ रहा है, बीच बीच में मिटाना भी पड़ता है. ओके, सो हियर दिस इज एंड फॉर टुडे. नेक्स्ट क्लास हम लोग वो लोकस बेस्ड ऑन आर्गुमेंट पढ़ेंगे. ओके, लोकस बेस्ड ऑन आर्गुमेंट एंड देन रोटेशन ऑफ कॉम्प्लेक्स नंबर्स एंड द क्वेश्चंस और प्रॉब्लम्स related to that. Bye. Good night. Sorry, good night क्यों बोलना. ठीक है, मेरे दोस्त बोल रहे, बोल सकते तो गुड नाइट. ओके, बाय, शब्बा खैर.